You guys are looking at B, okay? And again, I'm going to prove this to you guys, okay? When you guys are looking at B, it's really kind of important. B is a multiplier. So B messes up everything when there is a B and an H. Do you guys see how there's a B and an H here? There's a B and an H there. Yes. Whenever there's a B and an H, you have to have that little like siren saying, uh-oh, there's a like this can be tricky. I got to make sure I'm doing this correctly. Okay? So to find the B, when you have a B and an H, the best way to do this is to find the transformation is to set equal to 0. Okay, now watch me. What happens when I set this equal to 0? When I set the B and H equal to 0, what I'll have is 3x minus 2 equals 0. Add 2, add 2. 3x equals 2. Divide by 3, divide by 3. X equals 2/3. That is actually my transformation. I'll explain in just a second. Over here, I take negative x plus 1 equals 0. Set it equal to 0. Subtract 1, negative x equals negative 1. Divide by negative 1, divide by negative 1. X equals 1. That's my transformation. This is being shifted 2/3 to the right. What happened here? Yep, this is being shifted 2/3 to the right. This is being shifted 1 to the right. Now, how does that like make sense? Well, again, you got to think of B as a multiplier. So you got to think B multiplier. You got to think it has to be rewritten in a form where it's using distributive property. So what we're going to do is if I factor out a 3 out of both of these terms, it's going to look like this. Because what would happen if I multiply the 3 back? 3 times x is 3x. 3 times negative 2/3 is negative 2. Right? This is in the form B and H. That is not B and H. That's simplified version, but this is actually the form of how B and H works. In the same respect, over here, it looked like this. Do you guys see now? If this is now my B and H, this is a reflection of the y-axis. And then this is a shifting 1 unit to the right. Now, if you guys probably don't believe me, and you're like, why would I have to do all this work again, all this crazy stuff? So let's go and take a look at the graphs.
So if it's a stretch or compression, right?
There you go. Sorry about that. I'm sorry?
The stretch or compression is the same regardless of speed, right?
Yeah, the stretch and compression still is the same, but the shifting got messed up. Yes? During my instruction? The best part. Hold on. 3x minus 2. Guys, did that got shifted over 2 units to the right? No. I know it makes sense, but I'm telling you, where does it look like it's got shifted over? About 0.66? Yeah? About 2/3? Correct? Let's do the other one. This one is going to be the absolute value of negative x. What do you say? Plus 1? Plus 1. Oh, jeez.
Wait, you set y equal to 0?
No, you set b and whatever's inside the function equal to 0. So your b and your h equal to 0.
B or h?
No, whatever's inside of your function, 3x minus 2, set that equal to 0. Negative x plus 1, set that equal to 0.
Okay.
Do you guys see how this is not being shifted 1 unit left? Yes? You have to, I'm telling you guys, when you see a b and an h, you have to set it equal to 0 to get the correct transformations. All right? You can still use the b, or whatever the value is, as your compression or stretching, but you have to set it equal to 0 to find this stretch. Yes?
Does B mess with K or A or just H?
You mean it's only when B and H.
Okay.
Okay? The other last thing I just want to mention to you guys, there is a vertical stretch here. A lot of people kind of get confused with it because this is a symmetrical graph. But you guys can see here, b is still -1. It's still being reflected about the y-axis. And it's also being shifted to the right, right? Because I'd have to factor that out. Yes? Why you interrupted me twice? Yes, you may go.